Right now, we're going to solve an example of 2 degree of freedom system. So let's say we look at example number 1 here, but I have edited a bit on the question. So the question asks us, find the natural frequencies and mode shapes of the system shown given that K1 is equal to 30 Newton per meter, K2 is 5 Newton per meter, K3 is 0, M1 is equal to 10 kilogram, and M2 is 1 kilogram. So, as we know that this is a 2 degree of freedom system, since it has 2 mass here and 1 single axis, which is on the horizontal direction. So, in order for us to solve this problem, so first we need to determine the equation of motion. Okay, so equation of motion, normally in the end we will write it in matrix form. So, in order for us to develop the equation of motion, we need to start with the free body diagram. So how do we draw the free body diagram? First, we start with the mass. Okay, so we have 2 mass here, M1 and M2. Okay, next is we draw all the reaction forces that occurs on each mass. So for example here, let's consider mass 1. Okay, so on mass 1 we have K1 here, and we have K2 here. And we also have M1 x double dot 1. Okay, so now from single degree of freedom system, we know that K will be coupled with X. So we know that Kx, okay, the reaction forces. So K1 will react with X1. So this will become K1 X1. And the direction, okay, since we know that X1 is moving to the right hand side, so we know that K1 X1 will try to resist the motion of K1 of X1. So the direction will be opposite direction of mass 1. So mass 1 is moving to the right hand side, so K1 X1 will go to the left hand side. Okay, next we have K2 here. Okay, so we know that K2 is not only connected to mass 1. Okay, K2 is not only connected mass 1, it also connected to mass 2. So K2 will react with X1 and also will react with X2, since this spring K2 is connected to both mass 1 and mass 2. So the motion will be affected, K2 motion will be affected by X1 and X2. So on mass 1 we draw like this, K2 here and K2 here. So as I mentioned earlier, we have K2 X1 and K2 X2. So K2 X1 and K2 X2. So how about K2 X1? Okay, since x1 is moving to the right hand side, okay, since x1 is moving to the right hand side, so this k2 x1 will try to resist the movement of mass 1 to the right. So k2 x1 will move to the left hand side. Okay, so k2 x1 is to the left hand side. But how about k2 x2? Okay, so we know that x2 is moving to the right hand side. Does it mean that k2 x2 for mass 1 will move to the right hand side? No, not yet. So it's better that we leave this one first. Okay, now let's move on mass 2. So on mass 2, we have, so for mass 2 we have k2 and k3. So first we draw m2x double dot 2. Okay, next we know that mass 2 is connected to k2, so it's the same with mass 1. We have k2 x1 and k2 x2, and we also have k3 on the right hand side. Okay, so this is k3. Okay, so for mass 2, okay, for mass 2 it's the same. K2 is not only connected to mass 2, but it only connected to mass 1. So it will affect with two direction, which is x1 and x2. So for mass 1, since k2 x1 is going to the left hand side, so k2 x1 on mass number 2 will go to the right hand side. So it's the opposite of this one. Okay, so that's why I said it's better we determine mass 1 first. Okay, next is k2 x2 for mass 2. Okay, now since we know that x2 for mass number 2 is moving to the right hand side, so k2 x2 will try to resist the movement of mass 2 that try to go on the right. So k2 x2 on mass number 2 will move to the left hand side. Okay, so again we know that mass 2 is moving to the right hand side. Okay, because of x2, motion is to the right hand side, so k2 x2 will move to the left hand side. Okay, so since k2 x2 on mass 2 is moving to the left hand side, so k2 x2 for mass number 1 will move to the opposite direction of mass 2. Okay, and last one is k3 x2. So k3 x2, we know that mass 2, the x2 is moving to the right, so the spring of k3 x2 will move to the left hand side because it's the opposite direction. So now once we're done with the free body diagram, so we write the equation of motion. So sigma f, okay, going to the right hand side, sorry. So sigma positive f is equals to mx double dot. Okay, y to the right is positive because we know that mass 1 and mass 2 is going to the opposite right hand side, so we assume going to the right hand side is positive. So let's do for mass number 1 first. So sigma if m1 x double dot 1 going to the right is positive. So let's consider everything that we see in here. Okay, so m1 x double dot 1 is equals to negative k1 x1. Why negative k1 x1? Because k1 x1 is moving to the left hand side, minus k2 x1, because same k2 x1 is also to the left hand side, plus k2 x2. Okay, and we don't have anything else on mass number 1, so rearrange it. So m1 x double dot 1 plus k1 x1 plus k2 x1 minus k2 x2 is equals to 0. And we simplify m1 x double dot 1. Why do we need to simplify? Because in the end we're going to put it in matrix form. So write things with x1 first, then followed by x2. So m1 x double dot 1 plus k1 plus k2 x1 minus k2 x2 is equals to 0. So we are done with mass number 1. Next, we do for mass number 2. Okay, so again similar, sigma going to the right hand side is positive, f equals to m2 x double dot 2. So s2 x double dot 2 is equals to positive k2 x1. Why? Because k2 x1 is going to the right hand side, so it's positive, minus k2 x2 minus k3 x2. So bring everything to the left hand side. So m2 x double dot 2 minus k2 x1 plus k2 x2 plus k3 x2 is equals to 0. So m2 x double dot 2. Okay, so now we're trying to simplify it. So x1 with x1, x2 with x2, negative k2 x1 plus k2 plus k3 x2 is equals to 0. Okay, and then finally we need to write it in matrix form. So we know the general equation of motion is mx double dot. So for free vibration, because there is no external force, plus matrix k x equals to 0. So we write it as matrix M. So this is the M matrix. And then this is the X double dot matrix. So we have X double dot 1 here and X double dot 2 here, plus matrix K multiply with matrix X. So we have x1 here and x2 here is equals to 0. Okay, so now we just put in the value. So m1 x double dot 1, so mass 1 x double dot 1. So this row represent for mass number 1, and the second row represents for mass number 2. So m1 x double dot 1, okay, plus k1 plus k2 x1. So k1 plus k2 multiply with x1 minus k2 x2. So minus k2 x2 is equals to 0. So from the mass matrix, because we don't have anything else multiply with x double dot, it's only m1, so this one will become 0. So if we look again, if we check again, m1 x double dot 1, which is this one, plus 0 x dot double dot 2, because we don't have anything in here, plus k1 plus k2 x1, k1 plus k2 x1, minus k2 x2, minus k2 x2 is equals to 0. So similar thing, okay, 0 x dot 1 for mass number 2, okay, 0 x double dot 1 plus m2 x double dot 2, okay, minus k2 x1 plus k2 plus k3 x2. Okay, so this is basically the equation of motion in matrix form. Okay, so take some time to go through everything here and try to do it yourself. Please also take note that this thing is very important. If you wrongly determine the direction here, so end up you will mess up with the negative and positive here. So in the end, your equation of motion will be affected and you might get the wrong answer. So the rule of thumb is that in order for us to determine the the right hand side or left hand side, it's by looking at the motion or the direction of the mass. Thank you.